How's it going, everybody? So this is the first lesson in the sinusoidal functions unit. There are two different parts to this unit. The first one, again, we're going to take a look at graphs and characteristics of graphs of these sinusoidal functions. And then we're going to do regression in the second part of the lesson. So we're still going to be taking a look at the same characteristics that we did for polynomials and exponential and log graphs. But now we're going to be taking a look at something called a periodic graph. And what a periodic graph is, or what a periodic function is, it's when we get a graph that repeats itself over and over and over again. So it has like a consistent cycle to it. The main one that we're going to be looking at, well, the only one we're going to be looking at in this unit is the graph of sine. So we've used sine for trigonometry in the past, but if you graph the values of sine, like if you do sine of 1, sine of 2, sine of 3, blah, 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 those are all points that you can put on a graph. And they actually create this really cool looking wave graph. So the equation that we're going to be looking at, or the most basic version of it, is y equals sine of theta. And theta is just like my x. You can also use sine of x in this. By the way, just as an aside, there are a number of typos in here, so just kind of watch out for that. So we're going to be using y equals sine x, and there are going to be a number of values when we do regression that are going to change what this graph looks like. But for now, we're just going to stick with the basic. So there are some definitions here. These are some of the characteristics that you should be looking for. So in all of the previous units, we looked for x-intercept, y-intercept, end behavior, domain and range, blah, 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 blah. We're still going to be looking at domain and range. We are still going to be discussing x and y intercept to a certain extent, but in terms of the end behavior, there is not going to be an end behavior really, and we're going to take a look at why that is. There's also no like increasing or decreasing that kind of terminology, because it's like it continues to cycle. But again, we're going to take a look at that. So there are some definitions that we should know, and these numbers are going to sort of come up in throughout the next couple of lessons. So the first one is the midline, and that is the horizontal line which is halfway between the maximum and the minimum. So for the midline, we use the letter D to represent the midline. We're going to see why when we look at a more general version of the equation. And the way that you can calculate it is the max point plus the min point, and then divide that by 2. All right, it's just like taking the average of two numbers. That's essentially what the midline is. There's also something called the amplitude, and what the amplitude is, it's the distance from the midline to either the maximum or to the minimum. So because that midline is in the middle, the distance to the max is going to be the same as the distance to the minimum. Our amplitude is always going to be a positive number. We can also do a calculation similar to this, where we can say the amplitude A is equal to the maximum minus the minimum divided by 2. So again, if you ever need to do that calculation for whatever reason, that is a quick way to do it. The other last definition is called the period. And what the period is, it's the length of one of the cycles. So you can think of the length of one of the cycles as from one maximum to another maximum, or from one minimum to another minimum. All right, because once we hit that maximum point again, that completes one cycle. Or once we hit that minimum point again, that is also going to complete that cycle. And there is also a formula for the period. The period is, sorry, I need to look it up for 1 second. I always get this formula mixed up in my head. So the formula for the period is 2 times pi divided by the b number. And we're going to talk about what that b number is shortly. But the first thing we're going to do is we're going to draw the graph of sine, just to get a general idea of what the general shape of the graph is. Okay, so I have these values of theta here, 0, 90, 180, 270, 360. these are all going to be degrees. These are all degree numbers. Okay, so what we're going to do is we're going to graph y equals sine of theta, or sine of x, and we're going to take a look at the values of these points. So I'm going to switch over to Desmos. And now, because these points are all in degrees, if you click on the wrench icon at the top right, at the very bottom of this settings menu that comes up, you have two choices here of radians or degrees. By default, it is set to radians, and for all of the questions that we're going to do in this unit, they are going to be radians. But for this one, I'm going to set it to degrees, just because we're talking about degree numbers. You can also set it to degrees just in general, but just know you're going to get different answers for when we do some of these questions. So everything that we're going to do besides this, I believe, is going to be in radians. Okay, so this is what the graph of y equals sine of x looks like. And you can see it's just like an oscillating wave, basically. It looks very much like a wave. So if we look at the point at 0, the y value is also 0. If we look at the point at 90, the y value is 1. At 180, it is 0 again. At 270, we hit -1. And at 360, we hit 0 again. So again, if you were to do this on your calculator, you would just, if you did sine of 90, would get 1. Sine of 180 is 0, and so on and so on. So that's where those numbers come from. And we're going to go ahead and graph it as best as we can. So I'm going to switch back here to my notes screen. So I filled in that table with 0, 1, 0, -1, and 0. And in between, we hit a maximum value of 1 and a minimum value of -1. So I'm going to label those, and I'm going to label my degree values as well. All right, so it's going to look something like that. So when we go to draw the graph, it's going to look like a wave. And every time we hit a point here on the midline, my graph is basically going to change direction. So we get something that looks like that, and it continues in both of those directions. Now, if we look at the characteristics of this graph, let's fill these in here. So let's maybe just start with domain and range, because those are very familiar to us. So my domain, it keeps going all the way to the right, it keeps going all the way to the left. So it's going to be -infinity to infinity, or XER, whichever you prefer. My range, well, I hit a maximum point at 1, and I hit a minimum point at -1. So this is going to be the only type of graph where both numbers in my range are they're going to be numbers. I'm not going to have an infinity anywhere. And because those points are included, my range will always have square brackets to it. If we're looking at the y-intercept, well, it crosses at 0. And if we look at the x-intercept, it crosses at 0, it crosses at 180, it crosses at 360, and it crosses over and over and over again. So another way that we can say it is it crosses for every multiple of 180 degrees. Now, if we're talking about the period, so the period is how long it takes to complete one full cycle. So if we're starting here at 0, 0, it goes up, hits a maximum, comes back down. Now this is not one complete cycle, because it goes down again and then it comes back up again to hit that middle point. So if we were to continue to draw this out, it would continue to have this wave shape to it. All right, so this section that we drew here would carry on here, and it would carry on here and keep going like that forever. So this one complete cycle here takes 360 degrees. So that is my period for this graph. And then for the amplitude, well, the amplitude, we talked about it a couple of different ways. We said it's the distance from the midline to either the maximum or the minimum. So we're going from 0 to 1 or 0 to -1. We could also use this amplitude formula, where if we did max minus min divided by 2, no matter how you think about it, the amplitude of this graph is going to be 1. So flipping over to the next page, the graph that we just drew is the very basic form of sine, but there are going to be numbers that are going to stretch it and reflect it and move it in whatever way, move it up, move it down, but we can still look at the characteristics of those graphs. So we're going to take a look at two graphs here. We're going to find the midline, the amplitude, the range, and the period for each of these two graphs. Okay, so if we're looking at the one on the left, my graph goes between -1 and -5. So my midline would be right in the middle here, which is at -3. So that's halfway in between the top and the bottom. So my midline is at -3. My amplitude, well, if I go from -3 to -1, I'm going up by 2. If I go from -3 to -5, I'm going down by 2. So my amplitude is going to be 2 because that's the distance going up or going down. And again, we could also use the formula that I discussed on the previous page to find these 2 points. For the range, well, it's going between -5 and -1. And the period, so how long it takes to complete a cycle. So we want to pick 2 points where we can either find the maximum or the minimum and just calculate the distance between those points. So if I'm going from -3 to 1, I'm going 1, 2, 3, 4. So my period is 4. We could also take 2 minimum points, like these two here. So I'm starting at -1, I'm going over 1, 2, 3, 4. So no matter which 2 points you pick, the distance between them should be 4. But again, I would highly recommend sticking to either the maximum points or the minimum points because it's the easiest to find visually. Looking at example number, or the one on the right side. So now my graph is oscillating between 30 and -10. So halfway in between is going to be right here, which is at +10. So my midline on this one is going to be +10. My amplitude, well, I'm going from 10 to 30, so that's an amplitude of 20. Even if you calculate the one going down from 10 to -10 is a difference of 20. My range is how much the y values are fluctuating, so I'm going from -10 on the bottom up to 30 on the top. And my period, again, we're going to choose 2 points. I'm just going to stick to the maximums here. So I'm starting at -30 degrees and I'm ending at +30 degrees. So the difference between those is going to be 60 degrees. All right, so these are going to be the characteristics that we're going to be looking for on these graphs. And then, of course, the domain and the intercepts as well, possibly. So we're going to actually go ahead and graph some of these, but here at the bottom of the page, we have the general form of the sine graph. And again, I'm going to cross it out here. They wrote double sine here. So the general form of the graph is y equals a times sine, and then in brackets, bx plus c, close brackets, plus d. So there are 4 numbers that are going to show up in the graph, the a, b, c, and d. A, we already said, is our amplitude. D, we already said, is our midline. And this B number is what I was talking about on the previous page when we said the period is 2 pi divided by B. That's where the B number comes from. So in a pinch, if you're ever needing to do that calculation, that is one way that you can find the period. So on the next page, we have a couple of different equations. We're going to do a graph. We're going to find some characteristics. So the first one is y equals 4 sine x minus 0.5 plus 8. And again, I'm going to cross out this extra sign here. Let's go ahead and flip back to Desmos and type in that equation. So we have y equals 4 sine bracket x minus 0.5 close bracket plus 8. And you can see my graph is kind of off the line here. One of the other things that I'm going to do though is I'm going to go back into my settings and switch my mode back to radians and just kind of move my graph back. If you click the home button, it's going to bring you back to 0, 0 and kind of like not stretch things out anymore. So we get something that looks like this, where it looks like my minimum point is at negative 1.07 and 4. My maximum point is at 2.07 and 12. And so the distance between those 2 points looks to be 3. So yeah, we moved just a little bit over here, 5.21, and we're back at 4 again. So what we're going to do is we can calculate the amplitude. We can calculate the midline. We're going to determine the period of the graph. And we're going to draw the graph here as well. So if we are, let's start with the period. So these are my two minimum points here. And we're going from negative 1.07 over to 5.21. So if we go ahead and write that down here, and I'm going to switch back to the notes in a minute. So we have 5.21 minus negative 1.07. So make sure you watch out. There is a double negative there. And when you do that calculation, you get 6.28. And that is kind of a special number. If you do 2 times pi, because pi is 3.14, so if you times it by 2, you get 6.28. So I'm going to switch back here to the notes. And I just did that calculation right there. My period is 6.28, which is 2 pi. And another reason why it's 2 pi is because if we do the period calculation, which was 2 pi divided by b, well, in this case, I don't have a number in front of my x. The b number is always the number in front of the x. So this is just 2 pi divided by 1, which is just 2 pi. So no matter how you choose to calculate it, you should get 6.28 or 2 pi. Now the amplitude we said was the maximum minus the minimum divided by 2. So my maximum point was at 12 and my minimum point was at 4. When we divide that by 2, we get 8 divided by 2, which is 4, which is my number right there. If we want to calculate the midline, we said that's the max plus the min divided by 2. So that's 12 plus 4 divided by 2, which is 16 divided by 2, which is 8, which is the number that we have right there. Okay, so that's, again, we can look at the formula to figure out those points, or we can do a calculation to figure out those points. But if it gives you the equation, like, don't worry about doing the calculations, just write down what it is. And then we're going to look one more time to draw the graph of this. So I'm going to flip back to Desmos one last time. So I have a point at negative 1.07 and 4. I go to a maximum of 12, and that's at I can't remember what it is, 2.07. And then I'm going to go back down to a minimum point again at 5.21. And then I'm going to hit a maximum again at 8.35. So I kind of just plotted those points on my graph. I'll show you what it looks like here. So I put 4 points here on my graph. I labeled 4 and 12. And just draw the best wave you can through those points. So it's going to look something like that. Now we have one more question here, so let's take a look at example 3, which says, Ashley boards a Ferris wheel at the Red River X. When her ride begins, her position can be modeled by this function here. Again, there's a double sign, so I'm going to take one of them out. Determine the diameter of the Ferris wheel. How long does it take for the Ferris wheel to go around one complete revolution? And how high above the ground is Ashley when the ride begins? So I'm going to go ahead and punch this equation into Desmos, and then we'll discuss the questions. So I have my equation typed into Desmos, and I'll show you what it looks like here. Again, it's like there's a lot of waves, but we really want to try to single out just one of the waves, one or two. We want it to look more kind of, I guess, like zoomed in so we can get a better look at it. So we can see that we have a minimum point here at 4, and because the numbers, like my amplitude is 43, so it's going to be going up double of 43, or in this case 86. So I'm going to adjust my my window settings. The other thing that I'm going to point out is you can see that my waves are about, let's say, 2 units apart, because we're going from 0.45 to 2.24. That's what creates a whole wave. So maybe let's throw in a couple of waves so that we can get a good look at it. So what I'm going to do is I'm going to adjust my y-axis to go from, let's say, 0 up to 100. So now we can see the waves a lot better. We can see the bottom and the top. And my x-axis, let's make it go from -1 to, I don't know, 5, let's say. Okay, so now we can better see the waves, and we can determine some characteristics. So starting with the diameter of the Ferris wheel. So at the lowest point, the Ferris wheel is at a height of 4, and at the highest point, it's at a it has a y value of 90. So how can we interpret the diameter based on this? Well, what I'm going to do is I'm going to switch back to the notes and I'm going to draw a diagram. So a Ferris wheel is just a big circle like this. And what the graph said is that at my lowest point, the Ferris wheel is at 4, and at the highest point, the Ferris wheel is at 90. So if we are calculating the diameter, which is just the distance across the circle at its at its extreme points, we can calculate the diameter as being 90 minus 4, which is 86. And there's nothing here, like it doesn't talk about units at all. So this is probably, I don't know, 86 feet or 86 meters. I don't know how big the Ferris wheel at the Red River X is. Okay, but the diameter of it is going to be 86. When the question is asking how long does it take to complete one revolution, so one revolution is just going to be the period. All right, because we're starting at the low point, and we go all the way around the Ferris wheel, and then we're going to end at the low point. So that is going to be one period of our graph. So if we look at our graph here, and we just choose our two low points, so it's going from 0.45 up to 2.25. So if we subtract those two numbers, 2.25 minus 0.45 is about 1.8. And I'm going to assume in this case it's 1.8 minutes. All right, so our one revolution is 1.8 minutes. How high above the ground is Ashley when the ride begins? So again, when we're talking about something beginning, that means time is going to be 0. So in this case, time is my x value and my y value is height. So I'm going to look for x equals 0 and find the y value. And again, when x is equal to 0, that is my y-intercept. So in this case, my y-intercept is at 47.36. Right, so y is 47.36. So how high is she? She's at 47.36, and we'll just call it feet in this case. So there's a lot of stuff in this particular unit. It can be pretty hard to interpret things like the amplitude or the midline, just kind of figuring out the characteristics of the graph. But if you write down those formulas, or if you understand the numbers in the equation and where they come from, you should be pretty good to go.